First law of thermodynamics. According to first law of thermodynamics, the heat energy dq. According to first law of thermodynamics, the heat energy dq supplied to a thermodynamic system. Heat energy dq supplied to a thermodynamic system partly increases the internal energy of the system, and the rest is used in doing pressure volume work. Rest is used in doing pressure volume work. There is dq is equals to du plus dw. Sign convention. इसके आगे लिखो sign convention. Heat added to the system is taken as positive. Heat added to the system is taken as positive. And heat removed from the system is taken as negative. Heat added to the system is taken as positive, and heat removed from the system is taken as negative. If internal energy, second is if internal energy increases, du is positive. Bracket में you can write temperature increases. And if internal energy decreases, du is negative. And if internal energy decreases, du is negative. Du is negative. Bracket में you can write temperature decreases. Third chemistry से different लिखेंगे. Work done by the system is positive. Work done by the system is positive. And work done on the system is negative. And work done on the system is negative. Work done on the system is negative. That is, in expansion, work done is positive. In expansion, work done is positive. And in compression, work done is negative. And in compression, work done is negative. Next, you can write इसके आगे लिखो special cases. Special cases. अगर isothermal process है तो first law of thermodynamics क्या बन जाएगा? Isothermal process is one in which temperature remains constant. अगर temperature constant है तो तीनों में से कौन सी term zero होगी? du. Internal energy change नहीं होगा. That means whatever heat energy you supply, that will be used for doing work only. So first you can write isothermal process. In isothermal process, Temperature of the system remains constant. Temperature of the system remains constant. अगर टेम्परेचर कांस्टेंट है तो इंटरनल एनर्जी हमेशा कांस्टेंट रहती है या कोई स्पेसिफिक केस होता है? अगर मैं आपको बोलूं मेरे पास एक गैस है जिसका टेम्परेचर कांस्टेंट है, विल इंटरनल एनर्जी भी कांस्टेंट? अगर गैस का टेम्परेचर कांस्टेंट है, कैन आई से इंटरनल एनर्जी इज कांस्टेंट? यस और नो? इंटरनल एनर्जी किस पे डिपेंड करती है? इंटरनल एनर्जी टेम्परेचर पे डिपेंड करती है या किसी और चीज पे भी डिपेंड करेगी?
प्रेशर।
जो हम लिखते हैं उसको पढ़ भी लिया करो, कल लिखा था। आइडियल गैसेस के लिए टेम्परेचर पे डिपेंड करती है, नॉन आइडियल पे डिपेंड्स ऑन वॉल्यूम आल्सो, बिकॉज वहां पे इंटरमॉलिक्यूलर फोर्सेस आ जाएंगी। हमको पोटेंशियल एनर्जी का फैक्टर भी लेना पड़ेगा। सो यू कैन राइट फॉर आइडियल गैस, फॉर आइडियल गैस, बिकॉज नॉन आइडियल के लिए नहीं होगा। फॉर आइडियल गैस इफ टेम्परेचर रिमेन्स कांस्टेंट, change in internal energy will be zero. For ideal gas, if temperature remains constant, change in internal energy will be zero. That is, dq is equals to dw. This implies that if heat energy is supplied to an ideal gas, if heat energy is supplied to an ideal gas at constant temperature, all of the heat energy will be used. All of the heat energy will be used for doing pressure volume work only. All of the heat energy will be used for doing pressure volume work only. Second case is adiabatic process. Adiabatic process कौन सा होता है? Adiabatic process. No heat energy is exchanged between system and surroundings. So heat energy system और surroundings में exchange नहीं होगी, मतलब dq zero है. अगर dq zero है, तो first law of thermodynamics implies that du plus dw is equals to zero, और du is माइनस ऑफ डी डब्ल्यू। मतलब अगर वर्क डन पॉजिटिव है तो इंटरनल एनर्जी चेंज नेगेटिव होगा, वर्क डन नेगेटिव है तो इंटरनल एनर्जी चेंज पॉजिटिव होगा, which implies that expansion results in cooling. बिकॉज अगर एक्सपेंशन होगी तो वर्क डन पॉजिटिव है तो इंटरनल एनर्जी डिक्रीज करेगी, कि माइनस में आएगी, एंड सिमिलरली वर्क डन इज नेगेटिव, इंटरनल एनर्जी चेंज विल बी पॉजिटिव. सो यू कैन राइट एडियाबैटिक प्रोसेस. इन एडियाबैटिक प्रोसेस, in adiabatic process, no heat energy is exchanged. No heat energy is exchanged between system and surroundings. No heat energy is exchanged between system and surroundings. No heat energy is exchanged between system and surroundings. There is dq is equals to 0. From first law of thermodynamics. From first law of thermodynamics, du plus dw is 0, or du is equals to minus dw. This implies that if an ideal gas expands adiabatically, this implies that if an ideal gas expands adiabatically, work done is positive, work done is positive, and change in internal energy will be negative. That is, temperature falls. If ideal gas expands adiabatically, work done is positive and change in internal energy is negative, that is, temperature falls. Similarly, in adiabatic compression, similarly in adiabatic compression, similarly in adiabatic compression, change in, sorry, in adiabatic compression, work done is negative and change in internal energy will be positive. Therefore, temperature will rise. Therefore, temperature will rise. Isochoric process. कौन सा होता है? Isochoric process. Volume constant. Volume constant है तो work done 0. Work done 0 means whatever heat energy will be supplied will be used for doing changing internal energy only, because अगर volume constant है so this basically implies that work done will be 0 or dq is equals to du कि जितनी heat energy supply की that will be used for changing internal energy only. So you can write isochoric process. Isochoric process is one in which Isochoric process is one in which volume of the thermodynamic system is constant. Volume of the thermodynamic system is constant. As no expansion or compression takes place. As no expansion or compression takes place. Work done. As no expansion or compression takes place, work done. An isochoric process. Work done in isochoric process is 0. From first law of thermodynamics, dq is equals to du. dq is equals to du, which implies that whatever heat energy change takes place, an equal amount of change in internal energy is there. If heat is added to the system isochorically. If heat is added to the system isochorically, temperature will increase. If heat is added to the system isochorically, temperature will increase. And if heat is removed, temperature will decrease. So if we talk in terms of cyclic process, cyclic process कौन सा होता है? Cyclic. Cyclic process is one in which हम cyclic process किसको बोलते हैं? Where the system returns to its initial state after series of changes. मतलब जहां से थर्मोडायनामिक सिस्टम शुरू हुआ उसी स्टेट में अगर वापस आ गया तो इक्वेशन क्या होगी फर्स्ट लॉ ऑफ थर्मोडायनामिक्स की? First law of thermodynamics की equation for cyclic, because system returns to its initial state and internal energy is a state function. That means पूरे process में change in internal energy zero होगा. Change in internal energy zero हो जाएगा. That means dq is equals to dw. So you can write cyclic process is one in which the system returns to its initial state after series of changes as internal energy is a state function. Therefore, in cyclic process, change in internal energy is zero. Implies dq is equals to dw. Next is melting process. Melting process. In melting of any solid into liquid, the heat energy required to change the state is heat energy required to change the state of mass m is heat energy required to change the state of mass m is dq is equals to mlf, where lf denotes latent heat of fusion, when solid changes to liquid, change in volume is negligibly small. Therefore, work done is zero. Implies du is equals to heat energy supplied MLF. Next is boiling process. Boiling process. In boiling process, liquid changes into gas at constant temperature. When heat is added to the liquid at boiling point, when heat is added to the liquid at boiling point, if LV denotes latent heat of vaporization, if LV denotes latent heat of vaporization, then heat energy added to change m gram of liquid into gases. Heat energy added to change m gram of liquid into gases. MLV. Also, when liquid changes into gas, volume of the system changes from V1 to V2 at pressure P. Therefore, work done is
सर एक बार रिपीट कर दो वॉल्यूम ऑफ सिस्टम
volume
के
of
ऊपर
the liquid changes from V1 to V2 at pressure P. Therefore, work done is from first law. So you can write this के आगे. The equation for melting and boiling point signifies that. Equation for melting and boiling point signifies that there is change in internal energy at constant temperature if state of the system changes. If state of the system changes. If state of the system changes. Next is Myers formula. Cp minus Cv is equals to R. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स से हम ड्राइव करेंगे. CV को हम डिफाइन करते हैं that it's energy required to change the temperature of 1 mole of gas through 1 degree Celsius at constant volume. अगर 1 मोल का टेम्परेचर 1 डिग्री सेल्सियस चेंज करना है तो एनर्जी रिक्वायर्ड इज CV. अगर टेम्परेचर DT चेंज करना है तो एनर्जी रिक्वायर्ड इज, अगर टेम्परेचर 1 डिग्री सेल्सियस चेंज करना है तो हीट एनर्जी रिक्वायर्ड इज CV. इफ यू वांट टू चेंज द टेम्परेचर बाय DT, एनर्जी रिक्वायर्ड इज CVDT. अगर कांस्टेंट वॉल्यूम पे टेम्परेचर बढ़ा रहे हैं तो वर्क डन कितना होगा?
0.
Also be equals to du. So du is equals to CVDT. So ये हमने पहले भी एक बार रिलेशन यूज किया बिकॉज CV को हमने लिखा था CV is du by dt. So कांस्टेंट वॉल्यूम पे अगर आपने टेम्परेचर बढ़ाया है तो we say the heat energy supplied results in change in internal energy. Similarly अगर हम कांस्टेंट प्रेशर पे टेम्परेचर DT बढ़ाते हैं तो हीट एनर्जी रिक्वायर्ड इज CPDT. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या है? dq is equals to du plus dw. You can say CPDT and work done is PdV. अगर हम वर्क डन को PdV लेते हैं, this can also be written as because for 1 mole of a gas, one mole of a gas PV is equals to RT. तो PdV को क्या लिख सकते हैं? PdV can be written as RDT लिख देंगे, DT कैंसिल हो जाएगा, you will get the relation CP minus CV is equals to R. So you can write mass formula. ऊपर ये important है तो इसको ऊपर थ्योरी भी लिखनी पड़ेगी इसके थोड़ी सी. You can write. Consider 1 mole of an ideal gas. Consider 1 mole of an ideal gas enclosed in a cylinder. Enclosed in a cylinder fitted with a piston, which is frictionless. Frictionless ले रहे हैं because we don't want the energy losses. If the gas is heated, if the gas is heated keeping the volume constant, if gas is heated keeping the volume constant, the energy required to raise the temperature will be equals to change in internal energy. Energy required to raise the temperature will be equal to change in internal energy. That is, there is du is equals to temperature is raised through dt. Is at constant volume Work done is equals to 0. If CP denotes molar specific heat at constant pressure. If Cp denotes molar specific heat at constant pressure, then heat energy added to change its temperature, then heat energy added to change its temperature, to change temperature of 1 mole of a gas through dT is dq is equals to Cp dt. From first law of thermodynamics. So substitute 2 in 1. Cp minus Cv is equals to R. Next is isothermal process and work done in isothermal process. Isothermal process and work done in isothermal process. Isothermal process is one in which isothermal process is one in which temperature of the system remains constant. Isothermal processes takes place in containers with perfectly conducting walls and are generally slow so that time is available for exchange of heat between system and surroundings. Next paragraph में लिखो consider n moles of a gas placed in a container with pressure P1 and volume V1. If the gas slowly expands from volume V1 to V2, pressure will decrease from P1 to P2. If at any instant volume changes by dV when pressure is P, volume changes by dV when pressure is P, the work done is given by dW is equals to PdV. Temperature remains constant. Because isothermal process ले रहे हैं. nRT तो कांस्टेंट है dV by V. सेम आपने केमिस्ट्री में भी किया डेरिवेशन. log to the base n को log to the base 10 चेंज कर देंगे. Isothermal process है तो so you can also write work done as V2 by V1 की जगह you can also write it as P1 by P2. Graphically लें तो area under pressure volume curve is work done. This represents work done. Area under the graph. Slope of PV curve. क्या isothermal process के ग्राफ की अगर स्लोप निकालनी है तो so you can write in isothermal process as temperature remains constant. In isothermal process as temperature remains constant. Therefore, from ideal gas equation, isothermal process can be represented as PV is constant. Constant की differentiation 0. PV की differentiation क्या होगी?
PV plus VAP.
उसको हम लेंगे slope. So minus P by V. Negative slope signifies that. Negative slope signifies that. Pressure decreases when volume of the gas increases. Pressure decreases when volume of the gas decreases. Next is adiabatic process. Adiabatic process. Adiabatic processes are those in which no heat energy is exchanged between system and surroundings. No heat energy is exchanged between system and surroundings. And these processes takes place inside containers with perfectly insulating walls and are generally fast so that time is not available time is not available for exchange of heat time is not available for exchange of heat between system and surroundings. Time is not available for exchange of heat between system and surroundings. Time is not available for exchange of heat between systems and surroundings. From first law of thermodynamics. From first law of thermodynamics, if dq is equals to 0, du plus dw is also 0. If 1 mole of ideal gas expands, gas undergoes change in volume dV. Temperature changes by dt. So du is Cv dt plus Pdv is equals to 0. सेकेंड को फर्स्ट में सब्स्टिट्यूट कर दो dt की वैल्यू. Cv plus R is Cp. लगता है पूरी डेरिवेशन का ये. इम्पोर्टेंट नहीं है तो ज्यादा तो बुक्स ने डेरिवेशन एलिमिनेट कर दिया अपनी बुक्स में से. पुराने सिलेबस में भी नहीं दी थी, उन्होंने लिख दिया था ऑन सॉल्विंग वी गेट, तो सारे स्टेप छोड़ के ऑन सॉल्विंग कर दिया था. बट अगर आपको याद रखना है तो ये रख भी सकते हो, अदरवाइज एग्जाम में आने के चांस कम है. सो पीवी रेज टू पावर गामा इज कांस्टेंट. अब इसको हम कहते हैं दिस प्रेशर वॉल्यूम रिलेशन फॉर एडियाबैटिक प्रोसेस. अगर मैं आपसे ऐसी टेम्परेचर वॉल्यूम पूछूं तो हमें गिवन है पीवी रेज टू पावर गामा इज कांस्टेंट फॉर आइडियल गैस. So you get the relation as PV raised to power gamma minus 1 is constant. प्रेशर टेम्परेचर रिलेशन निकालना है तो वॉल्यूम सब्स्टिट्यूट कर दो. PV raised to power gamma is constant. V is question is p raised to power 1 minus gamma t raised to power gamma is constant. स्लोप निकालनी है अगर for adiabatic. Differentiate further with respect to volume. So minus gamma p by v. Isothermal में थी minus p by v. तो किसकी स्लोप ज्यादा है? किसकी स्लोप ज्यादा है? आइसोथर्मल की एडियाबैटिक की? Adiabatic की, because gamma is always greater than 1 Cp by Cv. So you can write this implies that slope of adiabatic process is gamma times the slope of isothermal process. As gamma is greater than 1, as gamma is greater than 1, therefore slope of adiabatic process is always more than slope of isothermal process. Slope of adiabatic process is always more than slope of isothermal process. तो नेक्स्ट टाइम करते हैं, ये देखो पहले, और बहुत सारी डेरिवेशंस की हैं आज, सो ये सारी एक बार खुद से करके देखना जो भी काम किया है.